We have our my third different lecture for today. You all are getting, unfortunately for you all, the probability lecture. The first class shows the introduction and project lecture. 9:30 shows descriptive statistics, so you all get probability as your. What I will be doing is I will be posting probably, and I might even try to do it during my break between my your class and my 2 o'clock class. I'll be posting the lectures for the other ones, so you can go through and look at those and hopefully catch up. There's nothing in the lecture that I'm giving you. You really need to know anything from the other 2 lectures to be able to understand this lecture. So that's one of the nice things. I do want you to go online on Blackboard. And in Blackboard, if you go into course documents, there should be a document which says like normal probability charts or something of that nature. You are going to need that for today. So you can just go online and download it and look at it as we're going through this material. I think it's a PDF file. So, yeah. So, and because you're videotaping, I'm going to be nice and just give you a copy.
Thank you.
So, I don't have enough copies for everyone. Whoever videotapes gets the good stuff. So, what we want to do today is we want to talk about probability. And probability is the link between descriptive statistics and inferential statistics, where descriptive statistics is we go out, we collect data, or we get a data set, and we describe the basic characteristics. So one thing that we'll be able to do is go through, we have a data set on housing prices, and we can go through and find out what is the average selling price of a house. What is the average number of square feet? What's the standard deviation on the number of bedrooms in a house, and so on and so forth. And from there, we're going to be able to describe that data set. What we eventually want to be able to do is we want to be able to describe, for example, have housing prices fallen on average? And so we could take a look at historic data where maybe we find that in the past few years, housing prices were so much, they're now currently this much. Have they fallen due to just randomness, or have they fallen due to something systematic? Or I could ask the question, looking back at my college years, we didn't have the internet or Facebook or anything like that for doing things. So, for example, do college students nowadays get less sleep because you have a lot more things that you can do than what we had to do in the late 80s, early 90s, besides, well, drink. And things of that nature. So we could go through and look at that and see, is there really a difference? So what the link is probability. Because the idea of probability is, or the idea of statistics is variation. That there's always variation things. So if I ask people, how long does it take you to drive from where you live to here on campus? You can tell me 20 minutes, but if I timed you every day, the amount of time it would take you to get from home to campus would vary a little bit. Okay. Now, is that variation due to just sort of random luck of, you hit this traffic light or you don't hit this traffic light, or the person in front of you on the beltway is going 40 in the far left-hand lane, or whatever the case may be? Okay. Or do I get here a little bit sooner because for whatever reason traffic was lighter today than it normally is? I don't know. But we're going to look at, is it due to something where it's just random and so you have that variation? Or is it things like, I know that if it's raining when I get up in the morning, I start coming to campus, that it's going to take me longer just because people drive more cautiously, there's a greater chance of an accident, of which I can say maybe there's a relationship between whether it's raining or not and how long it takes me to get to campus. So that's what we want to think about. Now we have a few basic rules. Well, we've talked about these already. first rule of probability says the probability of a single event must be between 0 and 1, where 0 means it's impossible, 1 means it's the sure thing. So we have that. Our second rule of probability Our second rule says the sum of the probabilities of all simple events must be 1. So if we take the probability, for example, of how many traffic lights you stop at, that if you stop at or if you go through 4 traffic lights, there's the probability you stop at none, there's the probability you stop at 1, there's the probability you stop at 2, the probability you stop at 3, and the probability you stop at 4. They all have to add up to 1. The individual probabilities would be between 0 and 1, but if we add up the sum of all of those, one of those events has to occur. So those are our 2 basic rules. Now, what we want to be thinking about today, though, is random variables. And when we talk about a random variable is any chance outcome. Okay. Any chance outcome. And you might even say, put unknown in here too. Maybe redundant, but that's okay. Is any unknown chance outcome that cannot be perfectly controlled or predicted. Pretty much honestly, anything is a random variable, if we want to define it that way. Now, the one that you're most familiar with, I think, overall, is if I toss a coin. When I flip a coin, so if I take this penny and toss it, okay, before I toss it, it is a random variable. I don't know what's going to happen. I can't control what will happen. I can make predictions, but I can't perfectly predict it at all. I mean, I can say it's going to be ahead, and about 50% of the time I'm going to be right about that. But 50% of the time I'm also wrong about that. So I can't perfectly predict it. I certainly can't control it unless if I have some magic trick or something like that. So it's a random variable. But actually, almost anything's a random variable. When you wake up in the morning and you start driving to campus, the amount of time it takes you to drive to campus is a random variable. We can't control it perfectly. We can't predict it perfectly. If I were to ask you, how many hours of sleep did you get last night? Okay? To me, that's a random variable. I can't control or predict how much sleep you get. Maybe on a test day I can control it to some degree, but I can't control or predict how much sleep you get. You know, if I ask a person, you know, what do you think of healthcare reform? Before I ask that person, it's a random variable. I don't know if they're going to say, I'm all for healthcare reform, I'm against healthcare reform, I like this, I don't like that. I don't know what they're going to say, so it's a random variable. So as I said, basically anything in the world can be a random variable, to be honest with you. Okay. Now, the key is